Hey everyone, today we're going to talk a little bit about analog. We've mentioned before, that analog input devices are things such as linear transducers and potentiometers, otherwise called speed pods. Also, an analog output could be something like a drive for a three-phase motor. So today what we're going to do, we're going to take a speed pod and we're going to hook that up as our analog input device, and that's going to be controlling, ultimately, our Allen-Bradley PowerFlex 4 drive connected to a three-phase motor. So I've already established communication via RS links with the PLC, and I'm using a 1747L532 right here. Okay. So the first thing I want to do is come over here and configure my IOs. Hit read IO config. As you can see right now, there's nothing showing in any of our input and output devices. Read IO config. Boom. See right here, number 4, the 1746 NIO4I, analog 2-channel in, 2-channel current out. That's the card we're going to be using. So our analog in is a 0 to 10 volt signal. So our potentiometer has 10 volts across the resistance, the resistor on it. And the output of this analog card is actually a 4 to 20 milliamp output going to the Allen-Bradley drive. And we need to remember that that's in slot 4. Alright, so the first thing we want to do is, how do we get our information from our potentiometer? Well, the easiest thing to do is to come over here to move, and we're going to put a move instruction on this first rung. Wrong one. We're going to put a move instruction on the wrong one. Our source is going to be I:4.0. Now the reason I'm using 4.0 is because we're using that entire word. If you remember, when we do our discrete inputs and outputs, we'll use a bit, and we know there's 16 bits in a word. Well, on analog, we are using the entire word, which would equal, in decimal format, 32,767. It actually would go, if we're using a negative 10 to positive 10, we'd go from negative 32,768 to positive 32,767. But we're using a 0 to 10 volt card, so our input's going to range from, our raw data coming from our card's going to range from 0 to 32,767. The next thing we're going to look at here is our destination. Where do we want to move this to? If the only thing we were doing was taking the input and turning them and controlling the motor with it, then we would just go ahead and put our output right here. But we're going to do a couple other things. So for our purposes, we want to put this information in N7:0. We talked a little bit about N7, and all that is, N7 integer right here, if you look at it, all that is a storage file for decimal numbers. So it's a data file made up of 16 bits that can represent a number from negative 32,768 to a positive 32,767. So 16 combinations of ones and zeros. If you look at your binary here, you got 16 combinations, 0 through 15, of ones and zeros. If we was to go in here to decimal, which I'd showed you all this in the last video, and type in 32,767, hit enter, we change this over to binary. As you'll see, your binary ones and zeros here are changing to match your decimal number. You want to set that back to 0 for now. So we've got our source and we've got our destination. Now this input is connected to a 5,000 ohm potentiometer, or most people call it speed pot. I verified my project, it shows that there's no errors. I'm going to go ahead and download this project. Call it Untitled, be fine. Yes, yes. All right, now we can see our values, 32,767 already. As I turn this potentiometer down, you'll notice it goes down to 4. That's probably because there's still a little bit of resistance remaining. And if, as we go up, we turn our potentiometer up back to 32,767. So right now we're doing nothing. We're taking this information from the analog input, we're storing it in N70. So let's go back offline and see what else we can do with it from there. All right, let's add another rung. And on this rung, let's scale it. Let's scale this number down. And I'll explain to you here in a minute what that scaling might do for us. Back one. All right. Now our source that we're going to scale, let's go ahead and say we're going to scale N70 because that's where we've stored our information. And the rate is how much you want to scale it down. And for this situation, I played around with it a little bit, so I already know kind of what I'm going to use in here. Most of the time you'll have to play around with it a little bit to find out what you're going to use. But we're going to scale it down to 30. And I'm going to put an offset of 2 in there. And my destination is going to be N7:1. Now if you notice, I didn't use N70 because that's where we're pulling the information from. I'm using the next available file that we can store that information in. So let's verify the project and go online again. Download. And click. Yes. All right, now if you look at my destination here, N70, right here, we're at 100. So we've scaled 32,767, which would be full speed for that drive. We've scaled that down to 100. So if we turn it all the way down, we've scaled it down to 2, which is close enough to 0. And let's say we go about halfway, we're real close to 50. So what would we use this for? Let's say on our HMI, we was wanting to display the speed by like a percentage, how fast that drive's running. So on your HMI, you would use the N71 file to display the rate of speed in a percentage that drive or that motor would be running. So if you turn it wide open, you're going 100%. You turn it down to nearly half, you're going to be close to 50. That's how you would display that information on your HMI if you ever needed to scale something down into a percentage or something like that. But still, with this project, we've never really accomplished anything. All we've done was take our information from our analog input or speed pot and scaled it down to show a percentage. But let's say, what do we need to do to make this information power that drive? Well, the way I would do this is I would put another move instruction in here, and I would take my source of N70 again, because that is our raw data we're wanting to use from our analog input card. Destination is going to be output : 4.1, because that's the terminal that I've got wired up to my analog in and output card. So let's verify everything looks good. Yes. All right. So right now, our drive, our analog input is on 4, N70 is on 4, N70 is on 3, output's on 4. So as we turn our potentiometer up, notice what's happening to our analog output. It's going up with it. But if you see right here on our scale, we're still at 100. So we can still use this to display a screen of 100% speed, and we're using this information to power the output. The way we were doing that, scaling it, putting it in a different file, using that file. Okay, but now let's say, for instance, this drive is hooked to a motor on a conveyor belt. Plant manager comes to us and he says, listen guys, we've got a problem. Conveyor belt A, the operator from conveyor belt A keeps cranking that thing wide open, and it's flooding conveyor belt B. We need to do something about this. We need to set it up to where he can't really run it no faster than a rate of 50%, which would be 30 hertz. So the way we would do that is we would change this move instruction here to a math instruction. I'll show you what we're going to do. We're going to delete this. We're going to come over here to, I think, math divide, and we're going to take source A, which is N70, and we could also use the analog input here, but we've already stored that information in N70, so we're going to use it. And source, okay, this source right here is, what are you wanting to divide it by? Okay, we're wanting to divide it by 2, because we're only wanting to run at 1/2 the rate of speed. So if we divide it by 2, they go from 60 hertz down to 30, or from 32,767 down to half of that. And our destination is going to be output : 4 point. Okay, now let's download this file. Yes. All right, so the operator now, let's turn this down. The operator now comes over here and he's saying, I'm going to crank this thing wide open. For whatever reason, he may be doing it, but the plant manager doesn't want it to go wide open. So he comes in here and he cranks it wide open. 32,767 is the input coming from the potentiometer that he was turning. Okay, now he's showing on the screen that it's running 100%. So as far as he knows, it's running 100%. But if you'll look down here to your output going to your drive, the output's only only putting out half capacity. So that drive is going to be sitting at 30 hertz right now. The motor's turning slow. Even though this guy's thinking he's running 100%, he's telling it to run wide open. We have in the program set it up to where there's no way possible for him to run at max speed. It has to be